so complex. I'm going to try to break it down as easy as I can, what I need you to know about it. Everything I'm telling you, what I need you to know is when you guys take the test, I want you to be successful. I don't want you to be thinking about every single detailed aspect of Huggins Principle because it concerns all waves. You know, it just takes place in sound waves as well, but it's more concerning with light waves. Okay. So let's talk about spherical waves and Huggins Principle, or Huggins Principle, or Huggins Principle. I don't care how you pronounce it. Just when you see that word, know what it means. Okay. So Huggins Principle, guys. Sound waves produced by very small sources of PZT diverge in the shape of a V. Okay. So even though we have our single element transducer, the particles that make that transducer up all emit smaller waves. Okay. And those waves interact with each other. Okay. Excuse me. These V-shaped waves are known as, you gotta know our synonyms, guys. It's a must. Okay. Spherical waves, diffraction patterns, or Huggins wavelets. Okay. Again, these V's, remember, is gonna come out in the shape of a V. Not a Z, not a D, not an F, a V. Okay, that's it right there. This is our sound source right here. It's gonna emit a wave in the shape of a V. We know our waves to be a straight line, right? Longitudinal, a straight line. Okay, and we're gonna explain why that's the consequence of using, something that has a small sound source, a small piece of PZT. Okay, the small sources producing these wavelets are known as Huggins sources. I like the way the book explained it. It don't give you too much information because if you happen to look up Huggins Principle, man, I've seen videos long as 30 minutes talking about this. Okay, so you can look them up. I have a little short video for us that we're going to check out, trying to explain it a little better. All right. So earlier, as we discussed, guys, large PZT crystals produce a beam shaped like an hourglass, right? Boom, there goes our hourglass right there, right? But our beam just doesn't come out, boom, hourglass shaped like that. You know, it's just not one beam and it's like, one wave and it's just making that shape. Okay? Because we know a sound wave to be a straight line, right? A sound wave is going to be in a straight line, right? So, however, small sources create beams that are V-shaped. A small transducer creating beams that are V-shaped. See our V-shape, V. I said it a couple of times, V-shaped. All right? This obvious inconsistency between large and small sound sources and their beams are explained with Huggins Principle. Huggins Principle states that a large active element may be thought of as millions of tiny distinct sound sources. Okay? Each of these tiny particles is a Huggins source and creates a Huggins wavelet with a V shape. Okay? So even though we have a piece of PZT, within that PZT, whatever makes that PZT up, the particles that make it up are also going to emit smaller wavelets. Okay? Those wavelets are known as Huggins wavelets, and they come out in a V shape. All right. Okay. So the hourglass shape of the beam by a large crystal is a result of interference. I should have highlighted that word. The result of interference of many Huggins sound wavelets emitted from those numerous sound sources. So how it works is, let's just say this is one strip of PZT, right? One strip of PZT. The particles that make up that strip of PZT are going to have different points of that particle. Think of like when you're, at the beach and you watching the tide come in, and you go out there in the middle, you getting rocked by those waves. You know what I mean? And so those waves, how we get the crest, that's two waves interacting to create a crest, right? And that crest is going to us when we're looking at it. Don't we look at our wavefront? Don't look like a straight line across, right? Look like a straight line. But those points are multiple waves that are interacting with each other, creating constructive interference. That's how we get our crest, and destructive interference is how we get our low points of that wave. Okay. So along that wave line, along that that wave front, it's multiple different waves that are creating in this case, creating our sound. Okay. Our sound comes out of our beam, and the interaction between those sources are going to have constructive and destructive interference. Okay, more constructive in the middle is we want to get our stronger, where our sound is stronger, and more destructive on the outside, which is why remember when you have complete destructive interference, don't those waves cancel each other out?
Mm-hmm.
Okay, that's how we get the shape of this beam right here, because the outside interference, these destructive waves are canceling each other out on the outside. We're getting more constructive interference in the middle. Okay? Some of the wavelengths are in phase that interfere constructively and creating an hourglass shape of the beam. Okay? Destructive interference also occurs where the wavelengths are out of phase and the sound beam is canceled. Complete destructive interference, because if it's just destructive interference, then that wave is going to be less intense, right? When these two waves meet at that same point, it's just going to be less intense, right? But if these waves interfere completely destructively, then they're going to completely cancel each other out, right? Just like if they interfere constructively, two of those waves are going to come together and they're going to create a larger wave, right? Right? Like I said, we never lose that information. It's always going to come back in. All right? So, this Huggins Principle explains, I keep changing the word I'm pronouncing. I'm sorry. This Huggins Principle explains the shape of the imaging transducer emitted based upon in-phase and out-of-phase wavelengths interfering with each other. So Huggins Principle is based on interference. Okay? Huggins Principle, guys, is based on interference. If you heard me repeat something, it's probably going to help you out with your quiz today. Okay? Huggins Principle is based on interference. All right? Just like phased array means multiple focuses, right? Adjustable focus. Okay? So many small particles in a disc-shaped crystal create an individual Huggins wavelet. They interfere, creating an hourglass-shaped beam. See these waves right here? Constructively interfering right here, more destructive on the outside, and you're going to eliminate those outside waves. Listen.
I'm sure it's not important, but are there videos where it explains how he found that out?
There is. I'm going to show it to you. I found the simplest one I could, because they're really in-depth videos about Huggins Principle. Okay? Because we know waves to be longitudinal, right? But at first, how that came about is that the scientist Young thought waves traveled, or Fresnel, speaking of Fresnel, he thought waves traveled as single particles. Come to find out, they travel in waves. Sound travels in single particles. Come to find out, it travels in waves, not a single particle. All right. So, again, that's how Huggins Principle works. This is our wave front. Different points along that single wave or that wave front, they're going to interfere with each other, and it's going to again create us to have a more V-shaped beam. See, our beam is V'ing out like this, right there. All right, guys. I had the video for you right here. Hope my speakers are working. All transmitted waves emit smaller wavelets that also emit sound waves. Because remember, it's just energy. Energy is being transferred, right? So that explains the shape of this beam. Just the interference among the different points within a longitudinal wave. All right. I still don't get it, man. I know it's tough. I still don't understand, right? Man, I still don't know what's going on with that. That's excellent. That's still fine. Why? Because this is what I want you to know about Huggins Principle right here. This is everything. This is my summarization of Huggins Principle right here. I want you guys to know that tiny pieces of PZT create V-shaped waves. Okay, these V-shaped waves are known as spherical waves, diffraction patterns, or Huggins waves. Get your picture, front ass. Get your picture. Okay, they are based on interference. Okay, Huggins Principle is based on interference of these sound waves. Okay, to create that hourglass-shaped beam. Okay. And that explains why the beam is hourglass-shaped based on constructive and destructive interference. Okay? I just want you guys to know the facts about that. Yes?
The hourglass. If you go back to that picture you just had, the transistor, the one before that, did he explain why it spreads out? I understand where they're...
Because at some point during the middle, it's going to be less and less points on that wavefront. Okay, that's when we get to the focus right here. and then it's still going to emit more and more. So, as far as the beam divergence, you know,
Did he explain? He didn't explain that.
I don't think he got that far because I cut the video off. I cut the video off. I don't think he got that far, but it kind of works like multiple points is gonna get smaller, and then it's gonna go from one point to get larger. I was glad to say. But even still, guys, this is what I want you to know right here about Huggins Principle. Easy right there. That's all I want you to know right there. The SPI is not gonna ask you the science behind Huggins Principle. You just have to know is how tiny pieces of PGT create smaller wavelengths. All right. I don't want to try to get a habit of teaching you more stuff that you guys need to know. Okay. So, bang! Thank you guys right there. Appreciate you. Guys,
Muchas gracias.
all right.